dependencies, then you get 25, right? Because each one of those had 5 of their own dependency. And you can see that this tree gets damn thick, damn fast, right? And by the time it gets to the user, that also has to also sees the dependencies of the operating system, of the cloud infrastructure, of the client technology that they are using, then of course the complexity is great. And moreover, it raises really interesting questions about trust and about security. And in the end, right, if there is a breach, if there is an exploit or a vulnerability within any of the chain that we saw, right, it doesn't really matter to the user. But who pays the highest price? Who stands to pay the highest price if a breach is taking place? It's obviously the user, right? And here you can see the user really wanting to be the user of a different service, right? Not your service, but some other service that didn't go through that breach. And obviously, we don't want that, right? So that brings me back to my original question, why do we care, right? Why DevOps, why software engineers, data scientists, TPM need to care about security? It's because we love our users, right? And we want our users to keep loving our wonderful software. So what it boils down to is we should care about security because we care about our downstream consumers and about our users. And you know, those users, they have expectations, right? It's funny that way. They expect that the software that they are using is adequately secure. Okay, let's give it the minimum. And they expect that the data is private. Okay? And those expectations can also be enforced, right, by governments, by courts, by regulators. Of course, we all know about Cyber Resilience Act, AI Act, US executive orders. All of those are ways to enforce those expectations on us, right, the software providers. And that's because a breach causes harm, right? It harms the software users, it harms our organizations, and we don't want that. We don't want that because that has cost. And cost has implications on our jobs, right? And it's not even that we can turn a blind eye, right, on these threat vectors, on this question of trust and security that I raised earlier, right? Because the numbers, if we look at the numbers of exploitations of this software supply chain, are increasing, right? So we can take 2024, we saw the same number as 2023 backwards, right? The sum of. And you know what? That was exactly my line in 2024, and it was my line in 2023, and so the problem is still there. So those are like your XZ Utils attack, right? Or the Log4Shell, Log4j, which everyone heard about, right? So these are the numbers that we see here. And you know, it's not just numbers. It's also the sheer sophistication of those attacks, right? So here, for instance, we see the time of the XZ Util attack, right? So you can see that the threat actor, presumably nation-state actor, that started planning the attack 2 years before it actually became exploitable. More than that, they noticed at some point that the final pull request that they would suggest to insert the malicious code would be detected by one of the CI/CD tools that runs a dynamic application security testing, right? OSS files in this case. So again, presumably, they disable this check at the source. And only then they could merge the final PR and be able to exploit that attack. Right, so the sophistication here is very, very impressive. And you know, for me, I work for Microsoft for a very special team. We love acronyms at Microsoft. I don't know if you know, everything is a 3-letter acronym. So my team is called Industry Solutions Engineering, or ISC, and we engage with hyperscale customers co-engineering customer success, you can say, right? So we co-engineer together with our customers, and obviously those customers, the biggest pharma, the biggest banking organizations, they care about this, right? They worry about that. So we started asking ourselves, as an org, how can we improve, right? How can we bring safer, how can we build safer software with our customers? So one of the first tools, and by the way, much of the work that we do is in open source, right? So we were looking for solutions that are open source and that address the open source supply chain security issues. So one of the first tools that we started using is Scorecard. Raise of hands, anyone heard using Scorecard? Okay, some hands, cool. What is Scorecard? So Scorecard is first and foremost an evaluation tool, right? It works on the repository level, and it's great for evaluating threats that are around, for instance, malicious maintainers, malicious packages, compromises to the source code, to the build system. And the way that it works, right, is that it analyzes the actual repository, so your settings on GitLab or GitHub or GitHub Enterprise or ADO, so three-letter acronyms, Azure DevOps. And it runs a set of 18 checks, which are built in. There are more checks, which are extension of those, but those are heuristics, right? So they address different types of security of threats in the open source security and the open source supply chain. Each one of those heuristics has a risk level associated to it, right? So you can think about branch protection, pretty risky, versus having CI tests, medium to low risk, right? And once we weigh all of those different heuristics together, we get a score of 1 to 10, which gives us a pretty good feel to the security awareness of the project. No more, no less, okay? And I'm saying this on purpose. Some use cases for Scorecard. So first, as an individual maintainer, when we work with our customers, one of the first things that we would do before we open source a project is run Scorecard to get a checklist, right, of things that we can improve. For instance, the branch protection can be improved. For instance, you don't have static analysis, right? You're not using code QL. Second use case is for an organization. So here we're leveraging the Scorecard action to run it on all of our repositories, right, under our organization, to keep an acceptable minimal value. Here, by the way, you can see a snapshot from the Microsoft Open Source Program Office, right? So those are the folks who are responsible for all of Microsoft organizations in GitHub. And we get, as you can see here on the far right, a score, also a historic score, and also a breakdown of those different heuristics over time for each one of our open source projects. Now, it's important to note, we don't require a minimal value, right? But even surfacing this in an easily digestible way for our developers helps, right? And the last part is for consumers, right? So here we are planning to consume a new dependency. So we run Scorecard to see if, again, to get a feel for the security awareness of the project. Now, I know you're probably already thinking, you know, I can put this on my build and break my build if a new dependency is added and it has a score lower than X. That's a bit more tricky because a lower score doesn't necessarily mean that it's not secure. A high score does mean that it is. So breaking a build on top of that is a bit tricky. That's at least our experience. And you can also leverage the open data that Scorecard has of the project that run the Scorecard action. For instance, here we can see it in dev.dev that you can go and see any PyPI, Node.js, NuGet package and see the breakdown of that score.